Let's be precise about what we're really asking, because it changes everything. We're not talking about an asteroid wiping out life on Earth. We're not even talking about something sterilizing every planet. We're asking what could destroy the entire solar system. Erase it, unmake it. Take the sun and all 8 planets and the whole vast machinery and end it, all at once. And here's the unsettling truth. The list of things that can actually do that is terrifyingly short. Almost everything the universe can throw at us would kill us while leaving the solar system itself spinning on, indifferent. But a few things, a tiny, strange handful of cosmic objects and events, really could take the whole thing down. And one of them could erase not just our solar system, but everything, at the speed of light, with no warning at all. So today we're going to walk through all of them. The real ones, the rare ones, and the almost impossibly unlikely ones. We'll separate the threats that merely kill everything alive from the ones that destroy the system as a physical object. And we'll build, step by step, toward the single most complete annihilation that physics allows. Let's begin with the one that's not a maybe, the one that's guaranteed. It helps to keep 3 levels of destruction in mind because they're wildly different in scale. Level 1. Kill all life, but leave the planets and the sun perfectly intact. A sterilized but otherwise untouched solar system. Most cosmic threats top out right here. Level 2. Physically wreck the system. Scatter the planets, fling them into the void or into the sun. Dismantle the orbital architecture itself. Only a handful of things can reach this level. And level 3. Erase the very fabric the system is made of. Not just break the planets, but unmake the atoms and the very laws of physics holding them together. Exactly one thing on our entire list can do that, and we're saving it for last. As we go, watch which level each threat belongs to. Because the jump from one level to the next isn't a small step. It's a leap across almost unimaginable amounts of power. Because the object most certain to destroy our solar system is the one at the center of it. The sun. Our own star is a ticking clock, and it will, with absolute certainty, devastate this system. We just have about 5 billion years before it happens. Right now, the sun is in the calm, stable middle of its life, fusing hydrogen into helium. But that fuel will run out, and when it does, the sun won't quietly fade. It will swell. As its core contracts and heats, the outer layers will balloon outward, and the sun will expand into a red giant, growing hundreds of times its current size. As it bloats, it will swallow its inner children one by one. Mercury first, then Venus, vaporized in the encroaching fire. And Earth sits right on the knife's edge. Recent models suggest our planet probably won't survive intact either, melted and possibly devoured by the swelling star. Every planet that survives will be scorched, its atmosphere blasted away by the dying sun's fury. And then the finale. After the red giant phase, the sun will shed its outer layers entirely, puffing them off into a glowing cloud, until all that remains is the exposed, dead core. A white dwarf, an Earth-sized ember of incredibly dense matter, slowly cooling for eternity. The solar system as we know it will be gone, the inner planets eaten, the survivors charred husks orbiting a dead cinder. This isn't speculation or a remote possibility. This is the confirmed destiny of our solar system, written into the physics of the sun itself. We've even watched it happen to other stars. Astronomers have directly caught a distant sun-like star in the act of swallowing one of its own planets. The greatest destroyer of our solar system isn't lurking out in the dark. It's the star we orbit, and it's already counting down. And the sun can lash out long before that final act too, though on a far smaller scale. Our star regularly hurls out enormous eruptions of magnetized plasma called coronal mass ejections and unleashes intense flares of radiation. A truly massive solar superstorm striking Earth directly could cripple satellites, fry power grids, and knock out technology across the planet. And history shows the sun has fired off such monsters before. This is, in a sense, the most realistic near-term space threat we actually face. Not in 5 billion years, but potentially in any given decade. Yet notice where it falls on our scale. A solar superstorm could wreck our civilization's infrastructure, but it wouldn't so much as nudge a single planet's orbit. The solar system wouldn't even register it. It's a reminder that able to ruin our day and able to destroy the system are separated by an almost unimaginable gulf of power. But 5 billion years is a long time. So let's turn to the threats that could come from outside and start with the most famous cosmic killer of all, the supernova. When a star far more massive than our sun reaches the end of its life, it doesn't gently swell and fade. It detonates in an explosion so violent that for a few weeks it can outshine an entire galaxy of billions of stars. A single supernova releases more energy in a heartbeat than our sun will emit across its entire 10 billion year lifetime. And it floods space with a tsunami of high-energy radiation, gamma rays, X-rays, and a torrent of cosmic ray particles moving at nearly the speed of light. If a supernova went off close enough to us, the consequences would be catastrophic. That blast of radiation would slam into our atmosphere and shred the ozone layer that shields the surface from deadly ultraviolet light. The result would be mass extinction, life on Earth scoured away, and every planet bathed in lethal radiation. And this isn't hypothetical. Scientists have found radioactive iron isotopes buried in ocean sediments, the fingerprint of supernovae that exploded relatively near our solar system around 2 million, and again around 8 million years ago. Close enough to leave traces, but thankfully not close enough to end us. The nearest massive star that could one day go supernova is the red supergiant Betelgeuse, around 640 light-years away. Dramatic to look at, but far too distant to seriously harm us when it finally blows. And there's a sneakier way to make a supernova that doesn't require a giant star at all. If a dead white dwarf, that dense, Earth-sized ember, happens to orbit a companion star, it can siphon off its partner's gas, piling matter onto itself like a cosmic vampire. Pile on too much, and the white dwarf detonates in a different kind of supernova, just as deadly. This matters because white dwarfs are small, dim, and common, which means a dangerous one could, in principle, be lurking closer than we'd ever notice. Far harder to spot than an obvious red supergiant like Betelgeuse. It's an unsettling thought. The next nearby stellar explosion might come not from a famous, watched giant, but from some quiet, overlooked dead star slowly feeding in the dark. Still, no such system is known to be close enough to threaten us, and like all supernovae, even a nearby one would be a sterilizer, not a system wrecker. But here's the crucial thing, and it's a theme we'll return to again and again. A supernova would devastate life, but it would not destroy the solar system. The planets would still be there. The sun would still burn. The orbits would barely twitch. A nearby supernova could sterilize every world in our system and leave the system itself fully intact. A set of dead planets still circling the sun like nothing happened. It's a planet killer, not a system killer. And that distinction is the heart of this entire video. Closely related, and even more focused in its fury, is the gamma ray burst. These are the most energetic explosions in the entire universe. They happen when an extremely massive star collapses, or when two ultra-dense neutron stars spiral together and merge. And instead of blasting energy in all directions like a supernova, a gamma-ray burst channels its power into narrow beams. Twin jets of gamma radiation firing out from the poles, like a cosmic searchlight of death. In a few seconds, one of these bursts can release more energy than our sun will produce in its entire lifetime. If one of those beams were aimed directly at us from within our own galaxy, it could strip away Earth's ozone layer in seconds, exposing all life to lethal radiation. Some scientists suspect that exactly this happened around 450 million years ago, possibly triggering one of Earth's great mass extinctions, the Ordovician die-off. And the most chilling part, because the burst travels at the speed of light, the radiation would arrive with absolutely no warning. One moment, the sky is normal. The next, the atmosphere is wrecked. But again, terrifying as it is, a gamma-ray burst is a destroyer of life, not of the solar system. The planets would endure. Only the living things on them would not. It's worth pausing on the strangest engines behind some of these bursts. Colliding neutron stars. A neutron star is the collapsed core left behind by a supernova, a city-sized ball so dense that a single teaspoon of its material would weigh billions of tons on Earth. When two of them orbit each other, They slowly spiral inward over millions of years, bleeding away energy as ripples in space-time, until they finally smash together in a cataclysm called a kilonova. That collision does two remarkable things. It can fire off one of those lethal gamma-ray bursts, and it forges heavy elements, hammering out gold, platinum, and other precious metals in the violence of the merger. In fact, much of the gold that exists anywhere, including on Earth, was likely born in such collisions long before our sun formed. So these events are paradoxes. They create the very elements that make rocky worlds and life possible. Yet a nearby one could scour those worlds clean with radiation. Fortunately, no neutron star pairs are known to be close enough to threaten us. But the galaxy holds millions of neutron stars, many still undiscovered. And some neutron stars are stranger and more violent still, the magnetars. These are neutron stars wrapped in the most powerful magnetic fields known to exist anywhere in the universe, trillions of times stronger than Earth's. Every so often, a magnetar suffers a kind of starquake, cracking its crust and releasing a colossal flare of gamma rays. The power of these flares is almost beyond belief. In 2004, a giant flare from a magnetar on the far side of our own galaxy, roughly 50,000 light-years away, actually reached Earth and measurably disturbed our upper atmosphere. 50,000 light-years away, and it still touched us. Had that magnetar been a mere few light-years from us, the burst could have done serious damage to our atmosphere and the life beneath it. Like their gentler kin, magnetars are planet threateners rather than system destroyers. But they're a vivid reminder of just how much raw energy the dead remnants of stars can unleash without warning. Now we get to the objects that can do more than just kill, the ones that can actually tear the system apart. And the first is genuinely the stuff of nightmares. The rogue black hole. Most black holes sit far away, but astronomers estimate there are around 100 million black holes wandering loose through our Milky Way galaxy. These rogues drift silently through interstellar space, utterly invisible. They emit no light, and unless they happen to be feeding on gas, there's almost no way to see one coming. Now imagine one of these wandering into our solar system. Unlike a supernova, this wouldn't just irradiate us, it would gravitationally rip the system apart. A black hole passing through would wrench the planets out of their orbits with its monstrous gravity, flinging some out into interstellar space to freeze in the dark, sending others plunging into the sun or colliding with each other. Earth could be hurled away into the void or swallowed whole. The entire elegant clockwork of the solar system would be scrambled and scattered in a cosmic instant. This is a true system killer, one of the few things that could genuinely end the solar system as a structure. The only saving grace is the math. The galaxy is staggeringly empty, and the odds of a black hole actually crossing paths with us are vanishingly, almost incomprehensibly small. But the number of them out there means the possibility is never quite zero. And the way it would unfold is the eeriest part. Because a black hole gives off no light, we might not even know one was approaching until the planets started behaving strangely. Orbits suddenly shifting, comets flung from their paths, the gravitational signature of an invisible intruder making itself known. As it drew near, its tidal gravity, the difference in pull across a great distance, could stretch and distort anything that came too close. A planet that wandered near enough would be torn apart, its material stretched into a glowing stream and potentially spiraling into the black hole's disk. There would be no explosion, no flash, just a silent, invisible monster reaching in and plucking worlds out of their orbits one by one, scattering a 4.5 billion-year-old system into the dark in a matter of years. It is perhaps the most quietly horrifying way the solar system could end. And a rogue black hole isn't the only wanderer that could unravel us. Consider the passing star. Our galaxy is in constant motion, with billions of stars all orbiting the galactic center on their own paths. And occasionally, those paths bring stars near one another. If another star drifted close enough to our solar system, its gravity could destabilize everything. It wouldn't even need to hit anything. Just by passing through or near the outer system, a star could gravitationally stir the planets like a spoon through water, disrupting orbits, triggering a cascade of chaos. Jupiter, our giant, could have its orbit nudged, and Jupiter in turn could fling the smaller planets around, knocking Mercury loose, hurling worlds into collisions or out into the dark. Earth could end up crashing into the sun, smashing into another planet, or being ejected from the system entirely. Like the black hole, a close stellar pass is a real system destabilizer. And like the black hole, it's reassuringly rare because of all that empty space between the stars. But over the immense lifetime of a galaxy, near misses do happen. There's a gentler cousin of this threat too, the rogue planet. These are worlds that were flung out of their own solar systems and now drift starless through the galaxy. And astronomers believe there could be billions of them out there, dark and frozen, and nearly impossible to detect until they're close. If a large rogue planet wandered into our system, its gravity could disrupt orbits, potentially shoving Earth out of the habitable zone and freezing our oceans solid. Here's the reassuring part, though. Most rogue planets are now believed to be relatively small, and a small one passing by wouldn't do catastrophic damage. It would take a giant, something Jupiter-sized, to truly wreck the system's orbits. And a wandering rogue that massive crossing our exact path is extraordinarily unlikely. Still, with billions of them roaming the dark, the possibility, however tiny, isn't zero. Now let's address one cosmic collision that sounds apocalyptic, but mostly isn't. The crash between our Milky Way and the neighboring Andromeda galaxy. You've probably heard that these two giant galaxies are on a collision course, destined to merge in a few billion years. It's true that they're approaching, though recent research suggests the head-on collision is far less certain than once thought. But here's the surprise. Even if the galaxies do merge, our solar system will almost certainly survive without a scratch. Why? Because galaxies, despite containing hundreds of billions of stars, are overwhelmingly empty space. The distances between stars are so vast that when two galaxies collide, the stars themselves almost never hit each other. They simply glide past, like two swarms of gnats passing through one another. The galaxies will reshape, the night sky will transform over millions of years, and our sun might get flung into a new orbit. But the actual chance of another star smashing into our system is minuscule. The Great Galactic Collision is a spectacular light show, not a solar system killer. Now let's drop down into the realm of the almost impossibly unlikely, the exotic threats that sound horrifying, but that nature has, in a sense, already proven harmless. These are the vanishingly small entries on our list. First, microscopic black holes and strange matter. There's a long-running fear, popular around particle physics experiments, that smashing particles together at enormous energies might create a tiny black hole or a bizarre clump of strange matter called a strangelet that could, in theory, convert everything it touches into more strange matter, a runaway reaction turning a planet to goo. It sounds like a doomsday scenario, but there's a beautifully simple reason we know it's safe. Nature has been running this exact experiment for billions of years. Cosmic rays, particles from space carrying energies far higher than anything our machines can produce, have been slamming into Earth, the Moon, Jupiter, and the Sun constantly for the entire age of the solar system. If these collisions could create planet-eating black holes or strange matter, we would see stars across the universe spontaneously turning into strange stars or vanishing into black holes. We don't see that anywhere. The universe has performed this test on a scale we never could, countless times, and everything is still here. Whatever you can imagine creating in a collider, nature has already created far more violently, and the solar system survived. So these particular nightmares, while real ideas physicists take seriously enough to check, are about as close to zero risk as anything can be. There's another kind of ending worth mentioning. Not a sudden destroyer, but a slow, inevitable unraveling that doesn't need any special object at all. Given enough time, and we mean almost incomprehensibly vast stretches of time, far beyond the sun's death, the universe itself winds down. Stars burn out. No new ones form. In some theories of physics, even matter isn't permanent. The protons that make up every atom may, over timescales with more zeros than you can fathom, slowly decay until matter itself evaporates. And the universe drifts toward what's called heat death, a cold, dark, formless state where everything has spread out into uniform, useless energy, and nothing can ever happen again. By that point, our solar system will have been gone for an eternity, its atoms scattered. This isn't a threat in any meaningful sense. It's the distant, quiet fate of all things. But it belongs on the list because it's the ultimate background against which every other ending plays out. Even if nothing ever hits us, time alone eventually unmakes everything. But there is one final entry, the big one. The only thing on this entire list that wouldn't just destroy our solar system, but would destroy everything, the planets, the stars, the galaxies, the very atoms reality is built from. And it could, in principle, already be on its way. This is false vacuum decay. To understand it, you need one strange idea. Empty space, the vacuum, might not actually be in its lowest possible energy state. It might be sitting in what physicists call a false vacuum, a state that seems stable, but is really just a temporary resting place, like a ball stuck in a shallow dip partway down a hill, rather than at the very bottom. And our best measurements of the universe's fundamental particles, particularly the Higgs boson and the heavy top quark, hint unnervingly that our vacuum may indeed be in this in-between, metastable condition. Stable for now, but not permanently safe. Here's why that's the ultimate catastrophe. If anywhere in the universe, through a random quantum fluctuation or some high-energy event, a tiny patch of space tunneled down to the true, lower-energy vacuum, it would form a bubble, and that bubble of true vacuum would expand outward at the speed of light, devouring everything in its path. Inside that bubble, the fundamental constants of nature would be different. The forces that hold atoms together, the masses of particles, the rules of chemistry itself, all rewritten. Every atom, every planet, every star the bubble swept over would simply cease to exist in any recognizable form, instantly disassembled into something governed by alien physics. It wouldn't blow the solar system apart, it would unmake it, erase the very ground rules that allow it to exist. And the truly horrifying details are these. Because the bubble expands at the speed of light, you would never see it coming. No telescope could detect it because the light announcing its arrival travels alongside the destruction itself. It would reach you at the exact instant it destroyed you. There would be no warning, no defense, no escape, and no pain. You would be gone before any signal could even reach your brain. It could be triggered anywhere within billions of light years of us right now and be racing toward us this very second. And there's a strange, dark mercy in it. Unlike every other entry on this list, a false vacuum bubble wouldn't leave behind charred planets or scattered debris. It would leave nothing, not even the physics that would allow nothing to be measured. Now, before you panic, the reassurance. The probability of this happening at any given moment is almost unimaginably tiny. If our vacuum is metastable, calculations suggest its lifetime is vastly, astronomically longer than the current age of the universe. We're likely talking about timescales so enormous they make 5 billion years look like an eye blink. The universe has already survived nearly 14 billion years without this happening. And we're not even certain our vacuum is metastable at all. Our understanding of physics is incomplete, and the true answer might be that the vacuum is perfectly stable, and vacuum decay is simply impossible. So this is not something to lose sleep over. It is, however, the single most complete form of destruction that known physics permits. The only thing on our entire list that could erase not just our solar system, but the universe itself. So let's lay them all out, from the certain to the impossible. The sun, which will absolutely consume this system in 5 billion years, guaranteed. The supernova and the gamma-ray burst, which could sterilize every planet but leave the system standing. The rogue black hole and the passing star, rare wanderers that could genuinely scatter and shatter the system, but almost certainly never will. The rogue planet and the galactic collision, mostly more spectacle than threat. The exotic nightmares of strange matter and tiny black holes, which nature has already proven harmless. And finally, false vacuum decay, the one true everything killer. Infinitely unlikely in any given moment, but absolute and total if it ever comes. What's strange when you step back is how safe we actually are. The universe is full of things that could end us, and yet here we sit, on a small blue world, around a stable star, in a quiet corner of an ordinary galaxy, having dodged every one of them for 4.5 billion years. The cosmos is not trying to destroy us. It barely notices us at all. And the most likely ending for our solar system isn't a black hole or an exploding star or a bubble of rewritten physics. It's the slow, certain swelling of our own sun, billions of years from now. A long, quiet sunset with all the time in the world still ahead of us.